Hey, what's up, guys? Yeah, so today, let's talk about another important theorem in the complex analysis called argument principle. Okay, so the idea is that you have a closed contour gamma on a complex plane, and you have a domain D, and F is a function which is meromorphic on D, and also but F is holomorphic, so it's analytic on gamma. So D is open set, though D is a domain enclosed by gamma. And let's say N is the number of zeros inside D. Okay, so you need to count multiplicity. Okay, and the P is the number of poles. And also count the multiplicity. Then is 1 over 2 pi I integration over gamma to the F prime Fc. So since F is holomorphic, so F derivative on gamma is well defined, will be this F minus P. So number of zeros and minus number of pole. Okay, and okay. The very simple example is this 1 over 2 pi I ddz, right? If this gamma enclose the origin, then you get 1 minus 0 because this is 1, because this is 0. Okay, so proof. Okay, so the probably not so obvious is one idea of proof is that you try to write f of z to be the, let's say, k from 1 to n. Let's say k from 1 to n. Let's say z minus pj, z minus nk, and this is j, and g of z. So this n1, n2 up to nk is zeros, the location of zeros, and the p1 up to pn is the position of poles. Okay, so you define, simply speaking, or one easy way to say that is that you define f, you write f in terms of this. So you just brute force did this. Okay. Okay, so this tell you that the g of z has no zeros inside this is our inside D. So g of z has no zeros inside D, and has no zeros, but has no poles inside D. Okay. So now we just brute force computer derivative. Okay, and you can prove by yourself if you do the derivative on this, and divided by f. You will get the following. You will get the following: k from 1 to n, 1 minus z minus nk, 1 minus j from 1 to, let's say, oh sorry, stupid, I should use p, and a capital P. P. Okay, so j from 1 to p, 1 divided by z minus pj plus g prime of z, g of z. Okay, now you can do the integration. Okay, these are very simple because now each gamma along z minus nk will just use this formula. Will be 1, right? If gamma enclose if 0, in this case, gamma enclose nk. So it's n minus p plus this. Okay, and by reparameterize, you know that if you map g to gamma to g of gamma, so g of gamma is the curve on another complex plane. This g of gamma will not enclose 0, right? Because this g of gamma has no roots. Okay, So G of Z is never be 0. Okay, so this term is always 0. Okay, so we'll prove the results. Okay, so right. Also, another way is to say that G prime divided by G is holomorphic. So by Cauchy's theorem, you get 0. Okay, this is the proof. Okay, so see you guys next videos.